So this is a short video on how to calculate t-tests on SPSS. So this is a basic general social survey data set, and I'm really interested in this question of the ideal number of children that people have. So their notion of what the amount of children they should have in their family. And to calculate t-tests, we go up into Analyze, and we go to Compare Means. And if you notice, there's you can just look at means, which can be kind of interesting sometimes, but we're going to mainly focus on these two different kinds of t-tests: the one sample t-test, which we very uncommonly use, and the independent sample or two sample t-test. The other options here are paired sample t-test, which is, for example, if you have a group that takes the same test at point time A and time B, you would use a paired sample t-test. So an independent sample t-test and a one sample t-test. We're going to do the one sample t-test first. So in a one sample t-test, we're only, it's not about the relationship between two variables, it's just about studying whether or not the variable that you're looking at is more or less or the same as a test value. So in this case, we know that the average number of children per household is 2. And so I'm testing whether or not people's notions of ideal number of children is same or different than the actual number of children that we have per household. So right down here, you have to write the test value in the whatever number you're going to be comparing this ideal number of children with. And that's all. You click OK. And in your output, the first box tells you things like the mean, right? Which, just looking at this, I wonder, maybe this is a little bit higher than 2, right? It's almost 3 here. The standard deviation, so we see actually quite a bit of variation in this variable. And the standard error of the mean, right? So it gives us that standard error automatically. Down here in this little tiny box, the very first thing that it tells us is what our t is. So just looking at this t statistic, it looks quite large. It tells us our, it tells us our degrees of freedom, right? And then it tells us our two-tailed significance. So if we want to have one-tailed significance instead, we have to divide this number by 5. Divide it by 2. Sorry, we have to divide it in half. In this case, it's telling us that the significance is 0.000, which means that it's incredibly small, right? It's like less than 0.0009. In fact, usually it is so far in that tail that the chances of there being an error here are like infinitesimally small. It also tells us the mean difference, and it gives us our 95% confidence interval of the difference. Right, so and that's the difference between our mean and our test value, which is 2, and it shows up here in your t-table. So the thing that we want to care about the most is this significance. We want to know, is it less than our alpha value? So is it less than 0.10 or 0.05 or whatever we set the alpha value at? So that's how to do a one sample t-test. Two sample t-tests are a little bit more complicated. So in this case, I want to compare whether or not subjective class identification affects the number of children that you have, or your ideal number of children. So I want to compare people in the working class, so that's people who answered 2 to this question, and people in the middle class, or 3. So if we go up into Analyze, and into Compare Means, independent sample t-test, compare the relationship between two different variables. If you notice up here, in this column, there's a test variable. This is a little bit bigger. And that's our interval ratio variable that we're going to be getting the mean of. That's our test variable. The grouping variable is which two groups we're going to be comparing. So we have to tell it which general variable. And then if you notice, it's not really sure which two groups within this variable we want to compare. So we're going to click on Define Groups and say, okay, I want you to compare people who answered 2, right, and people who answered 3. If you notice, you also have cut point as an option here. So if we were comparing age groups, like people under the age of 35 with people over the age of 35, we could just put, if we put age in, we could put 35 here instead. So it doesn't always have to be an ordinal or nominal variable. So I'm going to click Continue. I'm going to click OK. It's going to give me an even more kind of complicated little graph here. Right, so what this does, if you look up here, it gives us this first box, which has the means for both, right? And just looking at these look very similar. And also the standard deviations look very similar, right? So we don't have that homoscedasticity issue. If you notice, there's two different little boxes here. So there's the Levine's test for equality of variances. And this has to do with the assumption that we have relatively equal variances or standard deviations, right, in our between our two samples. And this is the t-test. So you should really notice, like, okay, there's two different tests going on here. One of them is an F test for equality of variances. One of them is a t-test. And what this does is that it means even with samples that the variances are very different, you can still use a t-test. So what we're going to do is we're going to read these first two boxes here. And what we really care about is whether or not this significance right here is more or less than 0.05. If this is not significant, if it's more than 0.05, we don't need to worry then. We can just move on and we can read our t here, which is negative 0.26, our degrees of freedom, and our significance. If for some reason this is less than 0.05, so it looks significant, that means that the standard deviations are quite different up here. And that instead of reading the regular t, we have to read an adjusted t down here. So in this case, we have this really big significance, 0.412. So we can just proceed and read this t value right here. Right? So the significance two-tailed is 0.795. If it's one-tailed, again, we'll divide it in half. So we can tell here that this is not statistically significant. That would have been our best guess up here, right? If we said that there was differences between these two groups, that people who are working class, they wanted more children, typically we would be wrong 80% of the time, right? So in this case, we failed to reject the null hypothesis.